Hello students, welcome to Sources classes. Today we will be solving the ISI Msqms question paper from the year 2017. Today we will be solving question number 14 and question number 15 from the same paper. So let's begin with question number 14. In question number 14, we have to find out the value of integration e to the power minus 1 to e square mod of log of x to the base e upon x dx. The options are 3 by 2, 5 by 2, 3 and 5. So we have to find out the value of the integration log of x to the base e upon x mod dx, which goes from e to the power minus 1 to e square. In such a structure, when a mod is involved, we have to find out the range where this structure is greater than 0 and where it is less than 0. We have to find out these cases. We have to verify. So let's start out by drawing the graph of log of x to the base e, or in short ln of x and x. So if we draw, this is the x-axis and this is the y-axis. Now ln of x is given by this part where it intersects the x-axis at x equal to 1. This is nothing but y equal to ln of x, and y equal to x is given by this part, and at x equal to 1, y of x, that is y equal to x, is equal to 1. This is the curve of y equal to x. So we can say that when x is greater than 1, then ln x and x both are positive. But when x is less than 1, then we can see that ln x is negative but y equal to x is positive. So in that case, we can say that for x greater than 1, then ln of x upon x is greater than 0, and for x less than 1, 0 to 1, ln of x by x is less than 0. So what we have to do over here, since we know that 1 lies between 1 by e and e square, so we have to break down the structure from e to the power minus 1 or 1 by e to 1 and then 1 to e square. So this will come down as equal to e to the power minus 1 to 1 log of x to the base e by x dx plus integration 1 to e square log of x to the base e by x dx. Now we already know that this is negative, so this we can write down as minus of log of x to the base e by x dx, which goes from e to the power minus 1 to 1 plus log of x by x, which goes from 1 to e square dx. This is the structure that we are looking for here. Now I'll use the space below. I need to move the space. Okay, now let's start solving the problem. So what we'll do over here, we'll find out the value of integration log of x to the base e by x dx. This is the value that we need to find out. What we'll do, we will find out by using integration by parts. So this will come down to log of x integration 1 by x dx minus integration 1 by x into differentiation of log of x to the base e. This will lead to 1 by x dx. So upon solving the entire thing, this will come down to log of x whole square minus integration log of x by x. So basically when we take this thing on the other side, then it will come down to 2 into log of x to the base e by x dx is equal to log of x whole square. This implies that integration of log of x to the base e upon x dx is nothing but half of log of x whole square. Therefore, integration e to the power minus 1 to 1 log of x to the base e upon x minus dx, this is equal to minus of log of x whole square by 2 upon, this goes from 1 to e to the power minus 1, and when we solve it, this comes down to 1 by 2. Now we'll solve this for the next part. In the next part, we have to find out the value of the other part, which is integration log of x to the base e by x dx, which goes from 1 to e square. This is equal to log of x whole square by 2. It goes from 1 to e square, and this is equal to 2. So overall, integration e to the power minus 1 to e square mod of log of x to the base e upon x dx is equal to half plus 2, that is equal to 1 by 2, that is equal to 5 by 2, which is option B. Now let's move on to the next question. In the next question, which is question number 15, it has been said that a function f is a quadratic function whose graph is a parabola opening upward and has a vertex on the x-axis. Okay, and the second part is the graph of the new function g, where g of x is defined as 2 minus f of x minus 5, has a range defined by minus 5 to infinity, 2 to infinity, minus infinity to 2, and minus infinity to 0. So we've been given that function f is a quadratic function whose graph is a parabola, and the parabola opening is to the up, and it has a vertex which is on the x-axis, and the graph of the new function, then we have to find out the range of the function g, which is defined by g of x is equal to 2 minus f of x minus 5. So let's start off by drawing the curve of f of x. So this is the x-axis, and this is the y-axis, and this is the x-axis. Sorry, I'm mistaken. And what we'll do over here, first I'll give something 1, 2, 3, 4, 5, 6. So this is 5. This very portion is 5, and similarly 1, 2, 3, 4, and downwards minus 1, minus 2, minus 3. Okay, now let's proceed. Let me use a separating for this process. Let me first draw f of x, and then I'll change the end. So it has been said that f is a quadratic function and the graph is a parabola which is opening upward and has a vertex on the x-axis. Suppose the vertex is at the origin 0, 0. In that case, we can draw f of x will be like somewhat like this. This we can write as f of x. This is f of x. Now we have to find out f of x minus 5. In f of x minus 5, what it will do, it will shift by 5 units towards right. So the next new vertex will be somewhere around here. In that case, f of x minus 5 will be given by this curve. This is nothing but f of x minus 5. And in the next case, what happens that f of x minus 5 has a negative sign in front of it, so it will rotate around the x-axis. So it will be somewhat like this. This will be f of x minus 5. And now in the next case, what happens that the g of x, there is 2 minus f of x minus 5. So g of x for f of x minus 5, this goes up by 2 units on the y-axis. So we can give that g of x, which is g of x is equal to 2 minus f of x minus 5. So the minus, the function which is given by minus of f of x minus 5, this goes up by 2 units on the y-axis. So this comes down, this will be the new vertex of the point, and the curve will look somewhat like this. 2, this is 5. Now we need to find out the range of the function g of x. Range of g of x. As you can see over here, the range of g of x will be, the highest value will be at 2, and then it will go further below. So the range of f of x will be starting from minus of infinity, and it will go up till 2, and then it will stop. So the correct option is option C, as mentioned over here. So today we have solved question number 14 and 15 from the ISI Msqms paper of year 2017. We'll be solving the next questions in the subsequent videos. Till then, keep watching Sources Classes videos for more solutions and content. Thank you very much.